Hello. In this demonstration, we are reviewing geospatial analysis in Python. To do this, we're going to use GeoPandas and Contextually. Python itself is just an open source high-level programming language, and in order to specifically perform geospatial analysis, we need these additional packages. GeoPandas is an open source project that was designed to facilitate working with geospatial data by extending the data types used within pandas. And then Contextually is a small package that helps users retrieve maps from the internet to layer with other plots or base maps. For this tutorial, we will use publicly available data via Seattle Geodata. This data has been made public by King County and is free to all members of the public. We're going to use 4 data sets, the shapefile for the Seattle neighborhoods, and then 3 GeoJSON files for public school data, and then traffic flow and street networks. Generally, I recommend using the GeoJSON files because they are smaller and easier to use, and they don't require a bunch of other files in conjunction with the main shapefile. Shapefiles require like a whole folder that you have to extract and make sure that all of the associated files are in the same location. So it's just, for this tutorial, I wanted to show how to bring in both types. So to start, we're going to plot polygons and points and walk through the code in our Jupyter notebook, but we'll basically get this graph here that shows the Seattle school neighborhoods and counts of schools, and then it colors them based on the total count. Then we're going to add a base map so we can see these neighborhoods layered over the actual geographic area. And then we can layer in even more analysis by coloring our dots or our points based on the type of school. And then finally, we're also going to plot traffic flow so that we can see how we can do analysis not just with polygons, but with other features such as lines or line segments. In this case, those represent streets. So to do this, we'll have to merge 2 data frames on a common key, and it will require us to do additional data cleansing and to convert to a reference system that is compatible with Contextually. So then we need to add a bounding box because you'll see when we do the initial code, we get too large of a geographic area and we can't actually see the traffic flow data. So we'll add a bounding box, zoom in on downtown Seattle, and then we can view our results for average weekly daily traffic in downtown Seattle. So in our Jupyter notebook, to start, we make a basic plot of polygons and points of interest. So we'll load the data, we'll do a spatial join, and this will bind together our shapefile of the neighborhoods with our public school data. And then we will count the number of schools and merge that back into the data frame as well, and then plot the results. And we use matplot and to do that since it's pretty straightforward. So after we run that, we get the map that we saw before. To add the base layer, we'll bring in Contextually, and we will make it a little transparent. So we set the alpha here to 0.5. We could change the marker size of our schools or the type of marker or the color, and then we'll add our base map. So we're going to use OpenStreetMap to do that, and then we will go ahead and set our title and run that to see our plot. Okay, after that runs for a few seconds, we have our new plot. We can see the underlying map and how our neighborhoods line up along that map, and then we still have those black markers for the school. So if we want to add another layer of analysis, we could color code those markers. So to do that, we're just going to switch up the transparency a little bit and then we will use the grade column as our school marker legend. And I increased the marker size a little bit, and then I chose a color schema, in this case plasma, so that we got kind of a good variation between each type. If we choose other color schemes, they sometimes are hard to tell the colors apart. So this one was the one that I chose. And then keep our base map, and and then we get this result. So now we can actually see, like, for example, in this neighborhood, there's no pre-Ks, one K through 8, a few K through 5s, and a middle school, 6th grade through 8th grade. Okay, so let's analyze line segments instead. So we'll import, we need a regular pandas as well. We'll load the GeoJSON files for traffic flow count, and then we need the street network database file as well. And they have this comp key is their common key. So first we need to make sure that we have comp key is a string, because it has not just numbers but mixed types like NAs in it. And then we want to filter out the rows where there is no comp key or we can't convert it to an integer. So we'll use a lambda function to run through and find the valid comp keys, and then we will go ahead and filter our traffic counts based on which rows have valid comp keys. Then we'll go ahead and convert to an integer and then merge the data frames together. We'll use an inner join for that. And then we need to use this function to merge the reference system so that it can layer nicely with contextually. And then we'll plot the merge data. So for this plot, we're plotting average weekday daily traffic, and we'll go ahead and add our base map to that using OpenStreetMap again. When we run this, we get this really wide geographic area, so we can see that our code worked, but we really can't discern much from this high of a level. So we're going to go ahead and zoom into a smaller area and create a bounding box. So I went ahead and chose the coordinates north, south, east, and west for that bounding box, and then created a shapely box using this box function. And then I just need to merge the data frame to include just the geometries that are included in that bounding box, and also make sure that I have that right reference system. And then we'll convert it back to map, and we will plot our data, add our base map, and then as you can see, now we have this bounding box here that is zoomed in on downtown Seattle, and we can actually see which streets are most congested and which streets are less congested.